Hey, I'm back and ready to talk electrical systems. The electrical system was easily the most intimidating part of my build. I had absolutely no previous experience, zero prior knowledge. So when I say that if I can do it, you can do it, I 100% mean that. It was really important to me to build my own system and to learn it rather than hire someone else to do it because if anything went wrong with it or I wanted to make any changes in the future, I wanted to be able to know how to do that on my own. So what I'm not going to do is spend this whole video talking about amperage, wattage, voltage drop, stuff like that, because there are already so many other videos out there that can explain it better than I could. And I will link all of my favorite ones that helped me the most below in the description. But what I am going to do is tell you about a little hack that I use that completely changed the game for me. But first, let's go over all the components of my electrical system so you can understand how it all works. So many of the videos that I was watching when I first started had like all Victron components and Battleborn batteries, and well, those were obviously great products. Like, I just couldn't afford all that. I didn't have any brand deals, I wasn't sponsored by anyone. My budget just wasn't that big. So I mixed some of those top of the line brands with some other really, really quality brands that I found, and I'm super content with how everything turned out. So we're just going to go over a very basic explanation of all of the components because I know that that's what I needed when I first started. Um, Grasping the concepts of how the electrical system functioned was super hard for me, so let's break it all down.
So the system has three main parts: the batteries, power distribution, and appliances. My entire van is powered by five 12-volt 100 amp hour smart lithium iron phosphate batteries from Renergy. I love these batteries so much. They have a ton of cool features like an on-off switch, which puts the battery into hibernation mode when not in use to prevent it from over discharge. Each battery also comes equipped with Bluetooth so I can monitor them in real time from my phone. There's a bunch of other stuff that makes them great, and I've linked them below so you can read more about it on their website if you want to.
500 amp hours is a lot of power, and not everyone needs as much power. I might have even gone a little bit overboard myself, but I just didn't want to worry about losing any power. I wanted to be able to park somewhere for days at a time without worrying about needing to recharge, especially when I was running some of the heavier duty appliances like Starlink and my air conditioner. There are several great resources online about how to size your electrical system slash battery bank for your needs. I found the blog post from the Far Out Ride one of the most helpful. Their entire website is one of the best resources for DIY van conversions, and I'll definitely add that link in the description.
The batteries are all connected in parallel, and each positive terminal is protected with a 250 amp fuse. The positive side is connected to a Class T fuse, which is connected to the master on-off switch. That is connected to the positive bus bar that connects to a 40 amp circuit breaker, which connects to the fuse block. The fuse block is how all the power is distributed to the appliances. The negative battery terminal is connected to the Victron Energy Smart Shunt Battery Monitor. This little thing provides detailed battery insight on your phone. The shunt is connected to the negative bus bar, which is connected to the fuse block. There is also a grounding wire that runs from the negative bus bar to the metal chassis of the van. Grounding the system to the chassis is a super important safety feature for many reasons, like if a live wire ever touches a metal surface, the current then has a safe path back to the battery or ground. This prevents electrical components and the chassis from becoming live and posing a shock hazard. A properly grounded system also allows fuses or breakers to trip quickly when a short circuit occurs, which protects the electrical components and wiring. Mark and Tanya, this YouTube channel, actually has a good video that explains it more in depth, so I'll link that below. Any battery charging devices and power conversions are connected to the positive and negative bus bars. I currently have two ways to charge my batteries and an option to add a third in the future. The first is through the DC to DC charger from Renergy. A black wire connects the negative terminal to the negative bus bar, and a red wire connects the positive terminal to a 60 amp ANL fuse, then to the positive bus bar. Another red wire runs from the charger to a second 60 amp ANL fuse, then connects directly to the battery of the van and recharges my batteries as I drive. This charger is also capable of charging the batteries via solar. I don't have solar yet, but I'm considering adding it in the future, and this would make it super easy for me to do. All I need is to buy solar panels and connect them to the correct terminals on this charger, and I'm all set. The second charging method is via shore power with the Victron Blue Smart Charger. Again, the positive terminal is connected to the positive bus bar, the negative terminal is connected to the negative bus bar, and then the device is connected to an external 15 amp AC outlet. Then I can just take an extension cord, plug it into any household outlet or at a campground hookup. I also have a 2000-watt pure sine inverter from Renogy. This converts DC power to AC power.
Actually, let's take a minute to go over the difference between DC and AC power because that's something I didn't even know when I started my build. DC power stands for direct current. It flows one way. That is the kind of power provided by like car batteries and the batteries that are in my van. AC power stands for alternating current, and that power flows two directions. It alternates, and that's the kind of power that you find in a house. So it powers household devices like my laptop, Starlink, and my hot water kettle. Whereas in my van, again, the DC power powers things like my fan and my lights. So because they're two different kinds of power, the alternating current and the direct current, you need an inverter to basically convert the power from my batteries, which are DC, into AC power to be able to use those household items like my laptop charger and my hot water kettle. So that's what that inverter does, is basically just change the DC power into AC power and allows you to use more items. There are different sizes of inverters measured in watts, and that just tells you basically how much power that inverter can handle. So there's typically three standard sizes: 1,000 watts, 2,000 watts, and 3,000 watts. 1,000 watts can hire like smaller appliances like a phone charger, stuff like that. 2,000 watts is kind of that sweet spot. That's what I have. That's what a lot of van lifers have, that can handle slightly more heavy duty things. It can handle a microwave, a small blender, a coffee maker. I don't have any of those things, but if I wanted to, my inverter could handle that. And then 3,000 watts is like ultra heavy duty. That's what you would want if you're running multiple high power appliances at once. So like running a microwave plus an induction cooktop, or even like power tools. If you're running all those things at once for whatever reason, I don't know who's microwaving and running a grill or whatever at the same time, but if you were going to run all that at the same time, you definitely want to upgrade to a 3,000 watt inverter. You can find out what size inverter is best for you by adding up the wattage of all the appliances that you think you might run at one time. Obviously, the bigger inverter, the more power it can handle. Bigger inverters also draw more power from your batteries, so just remember that when you are choosing your size. I have an on-off switch located underneath my sink, so I can turn my inverter off when I'm not using it to power any of my AC or household items. And that's about it for power distribution, so let's move on to talking about appliances. Oh, actually, no, I do have one appliance that is hooked up to my bus bars, and that is my air conditioner. It is too powerful to run off of my fuse block, so that's why it's hooked up to my bus bars instead.
My air conditioner was the single most expensive component of my whole electrical system. If it were up to me, I wouldn't have even got it. But since my dog is like a little husky with a thick fur coat, she gets hot super easily. Even in like 65-degree weather, she's dying. So during the summer, or if I go to Utah or the deserts to the southwest, I have to keep her cool somehow. So air conditioner was a must for me. I looked at quite a few different models and decided to go with the Dometic RTX 2000, mainly because it's one of the only air conditioners on the market that runs off of DC power, which is way more efficient than trying to convert it to AC. It's also lower profile. Like a lot of the other models were pretty big and added at least a foot of height to the van. And my van was tall enough. I didn't want to add that much height. And the RTX only added about 6 inches. There's a ton of other great features on it, so I will definitely add a link below so you can look it up and do your own research on air conditioners. All my other appliances are powered through the fuse block. This includes my fan, water pump, fridge, USB charging outlets, etc. Basically, how it works is each appliance has a positive and negative wire. The positive connected to the positive side of the fuse block, the negative is connected to the negative side of the fuse block, and then each appliance has a fuse.
Okay, so that's the breakdown of all the different parts of my system. Now let's talk about how we wire it all together and my little hack to make it easier. When I started my build, I actually had a friend who's an electrician that said they would help me, and then they ended up bailing, and I freaked out. I was just super overwhelmed. I found it really hard to grasp all the concepts of electricity. And sometimes even going through YouTube and watching the different videos was even more overwhelming to me because everyone's electrical system is unique. So, unlike installing a fan or plumbing, you can't just copy and paste someone's electrical system into your van. You can't copy exactly what one person is doing because chances are you're going to have different components or appliances than they are. One of the most important things to get right is the wire sizing. You have to make sure your wire sizing is correct because if you get the wiring size at all wrong, it can cause voltage drops, power outages, and even start fires. There are three main things you need to know when trying to find the right size wire. One is current, or amps. This is how much power the component will pull. The higher the amps, the bigger the wire you need. Number two is wire length. The longer wire, the more resistance, which means the longer wire that you have, you need it to be thicker so it can withstand voltage drops. And then the third one is system voltage. We are working in a 12-volt system. That basically means like a 12-volt system, the DC power versus AC power in a house. The voltage drops are just more noticeable, so we'll usually need thicker wire to power everything than you would need for an AC system or that you would find in a house. I really wanted to make sure that I not only got my wiring sizes right, but that all of my components in my system were compatible with each other, and there isn't just a wire calculator that can do that. So, I decided to use AI or ChatGPT to help me build my electrical system. ChatGPT literally became my personal electrician. So if you haven't used ChatGPT yet, you can get a free version, which I'll link below, but I do recommend the paid version. It's $20 a month and you can cancel after you're done, but it can search the internet in real time, which means that it's less work for you. Or it could search all of the devices, like the brands that I was putting in my van, and give me real time like specs and all the information I needed on that. And that just gave me a lot of reassurance because that way I knew I was getting the right information. I knew I was getting the correct amperage and wattage. So here's my process. First, I bought all of my components. Fuse blocks, batteries, inverters, chargers, etc. Then I installed them where I wanted them in the van. Then I measured the space in between each component and put it all into ChatGPT. So my conversation with ChatGPT would look like this.
I am connecting 5 12-volt 100 amp hour smart lithium iron phosphate batteries from Renogy that are connected in parallel that are roughly 1 foot apart. What size wiring would I need? And then it gives you this full answer. Then I'd move on to the next piece. I am connecting the negative terminal of the battery furthest away from the battery minus bulb on a Victron Energy Smart Shunt 500 amp hour battery monitor that is 4 feet apart. What size wiring would I need? And again, another perfect answer. I did this for every piece of my electrical system and then put all the answers into one huge master document. I'll also link a copy of this in the description so you can use it as a template or something if you want to. Now that I had all the wire lengths calculated, I could order the correct amount for each size. Just remember to order a little bit more than you usually would need because you are going to make mistakes and need extra, and I learned this the hard way. I also asked ChatGPT to go over and double check all of the components and appliances to ensure that they were compatible with each other. Then I made this diagram so it was easier for me to visualize everything, and I'll drop it in the description too. I copied the entire format from the Far Out Ride. I'll link their site too because it's one of the best resources possible. They actually have a customizable diagram with a built-in calculator that you can pay to download. And they have some amazing blog posts explaining everything you need to know about the electrical system in a van, which I highly suggest reading.
And that is how I used AI to help calculate and double check all the components and wiring sizes of my electrical system. Now, if you have more previous experience or understanding of electricity than me, then you probably don't need to do this. But as someone who had no idea what they were doing, AI was an absolute lifesaver for me. I actually ended up using it for more than just my electrical system too. I would ask it questions like compare and contrast different models of air conditioners to find out which one was the right one for my van, and help me find an amazing joint compound that was best suited for my needs of like my ceiling, and adhering all of that together underneath the micro cement. I just ended up using it more than Google and more than YouTube at the end. So if you aren't using AI to help you with your build yet, I would suggest trying it in some way. I hope this video was helpful for at least one person. Um, I have absolutely no complaints about my electrical system so far. I've had zero issues with it. I've never drained the power. Nothing has ever gone wrong yet. Um, but at least I know that when it does, I will be able to fix it, and I can always ask ChatGPT for help. But now I have at least a baseline understanding of how everything works, and I know that I can troubleshoot any problems that come up. I linked all the products that I use, my ChatGPT master document, my wiring diagram, and all the blogs that and videos that were the most helpful for me when I was doing all this. As always, drop me a comment if you have any questions. I'll do my best to answer them. Next video will be a total breakdown of how much it costs to build this thing. See you next time.